Hello again. We talked about RAG systems and the technique, whether it's on the naive and advanced side. And I encourage you to take a look at the previous videos if you haven't already. But one of the subjects that I want to touch on is embeddings, which is part of the retrieval component of RAG systems. And it's a component that with high importance not only into RAG, but to the transformer architecture, to natural language processing in general, because embeddings gave a lot of power for machines to understand the semantic meaning of words in language. So that made the advancement and was a big component of the transformer architecture and the success of it in large language models. I want to touch on embeddings and what does it mean for the RAG technique. And if you want to dig more into embeddings and how it works, I would encourage you also to look at other videos so you have a deeper understanding of it. Embeddings are a vector dense representation of text. So if we look together here on a simplified 2D, of course, we're talking about high dimensional space. So this is just very simplified. If you are looking for the word physician, you will find that an embedding for the word doctor would be very close to it, and which means those two embeddings or two vectors are similar semantically in the meaning. While at the same time, if I go to looking at doctor and the word banana at the same time, you're going to find out that I'm way far away. Same thing for the word car, that is going to be pretty close to automobile, and at the same time, pretty far away from the word banana. That also far from it from semantically, from the meaning of it semantically. And so embeddings gives us this power for RAG systems to actually take whatever we have as prompt. Let's say someone asks the question, explain to me what's AI in healthcare. And my embeddings I'm storing in my retrieval system. I'm storing paper talking about how, AI in healthcare or machine learning in healthcare. If I create embeddings from all the chunks, let's say this book or the paper is of 20 pages, and for each page I made an embedding and I saved it into my database. Now, when I prompt my RAG system to say, talk to me about AI in healthcare, this prompt is going to be turned into an embedding, and that embedding, we run a similarity search on the other embeddings that we saved from the paper that talks about machine learning in healthcare. And it's going to grab the closest or the most similar document that has any information related to AI in healthcare, which mainly is going to be the page that has context about machine learning in healthcare. And you can notice that machine learning and AI, they're not similar words, but semantically, they are close to each other in this case. So in our case, AI would be here in healthcare, and machine learning in healthcare will be here. So in this case, the system will retrieve for us the most similar results that is related to our prompt and give it us back. So now we have the context, that chunk, the embeddings that we have. And that embedding, of course, it's attached to a raw text that is human readable that we can actually take and provide and augment our prompt with before going to the large language model. So we can see the benefits of using something like embeddings and vector databases, because this allows for us the power of semantic meaning that we don't get from full text search or simple keyword search that we do through, let's say, Lucene based solutions, or even like specific keyword search on Google that is not going to give you the same results. So we can see how much powerful embeddings can be in actually boosting our RAG system so it can be very useful to our customers and our users. So now if we go back to our simple RAG architecture that we drew before, we're going to actually, and the example that we have, we're going to break this down using embeddings and a vector database. So you have a prompt that comes in that says who won the Super Bowl in 2025, and you have an article about the Super Bowl 2025. What you can do is you can actually either you take the whole article and you create an embedding out of it. If you have multiple articles, each article could be an embedding by itself. It's a lot of context in an embedding, but it depends on the embedding model that you're using, depends on the dimensions of the embeddings that you're generating, because and I can confirm this, but mainly bigger dimensions means it's going to hold more of the semantic meaning and more of the details. But let's say you only have one article that you're working with. What you can do is actually split this into, let's say, chunks. And these chunks are paragraph one of the Super Bowl 2025 article, paragraph 2, paragraph 3, paragraph 4 in this case. And what that does is, let's say this article holds a lot of themes. You only need the paragraph that can answer the question for you. So what happens right now is that you take those paragraphs, each one of them, you create an embedding out of it. So there is an embedding here, 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 and here, and this is your vector database. This is your vector database. So this is embedding for paragraph 1, embedding for paragraph 2, 3, and 4. Now, once the prompts comes in, what you're going to do is you're going to create an embedding for the prompt. Once you create an embedding for the prompt, you're going to do a search here, a vector search, similarity search. And once you do that, you're going to get back results, and it could be multiple results, and you can choose how many of the returned results you want to accept. Let's say we want to accept only one. That's all we need. So let's say if it's paragraph 2 comes back, and now this paragraph 2, it's not only holding the embedding, it's also holding the raw text of this paragraph that you need. So it has the raw text of it. So once it comes back, now this is getting convoluted, but once it comes back, I'm going to add it to here plus context and send it to my LLM. So now I send the prompt and I send the context that I need from my vector store. Of course, there's many vector stores that are either open source or they have some kind of free plans. But again, like most of them are becoming more production level right now. But the ones I know is like VBA and Pinecone, and Postgres itself has its own extension that can actually enable you to save embeddings into Postgres. So there's many ways that you can store embeddings, and I hope that was informative and builds on the same concepts of the RAG technique and why embeddings is important. Thank you so much.
For Robbie Innovations.